Okay, so this is actually a reasonable question about like why do we need two starting things when we have a second order differential equation? So I'm going to use Anthony's unicycle to illustrate some of this. Okay, so I have here kind of a pendulum, right? You guys all with me on the pendulum aspect of this particular object? Okay, so when I started this thing moving, what did I give it?
Initial velocity?
Yeah, I give it some kind of initial velocity from some starting point, right? So like up here, I might just give it an initial velocity of 0 and a starting point, right? And it's doing something. We could get it to do something else if I gave it a different initial velocity, right? Like if I give it a little up, it does something slightly different. You guys see that? Cool with us? So that's what those two pieces of information are, right? In a first order differential equation, I just feed it an initial position, right? Like I say, at time 0, it's at 2, right? That would be y of 0 is 2. In a second order differential equation place, I can give it two kind of starting inputs. One is an initial position and the other one is some kind of initial velocity. You guys with me on that? Okay. In order to think about the kind of solution curve picture, right, the little like arrows, you might think instead of about the qualitative behaviors that are exhibited. So if I just kind of start this guy swinging back and forth, right, given some sets of initial conditions, it's just going to swap, right, height for velocity and back and forth. You guys see that? You see the trade that I mean when I'm saying it's swapping height for velocity?
Yes, the potential energy transferring kinetic and
Yeah,
back and forth.
exactly.